Okay, so the calculations are pretty interesting, actually. So what are we going to have to try to calculate?
Well, we could calculate we could calculate all of the outcomes of like playing this.
Okay.
Like even like with less, like because we have to calculate if he wins like these two games, we have to calculate win, win, loss.
Yeah.
Or like win, loss, win, and then
okay.
see what those all add
So
up
how
to.
many outcomes are there?
So there's going to be 8 different outcomes.
There's going to be 8 different outcomes. And we could calculate all 8. That would work.
But we don't need to.
What do we need to do?
We need to calculate the probability of him winning these 2 games and him winning these 2 games.
Okay.
And losing the other game.
Or we could also calculate the probability of him winning all 3 as well.
I think that still applies, but then we just have to kind of roll it into the first case.
Yeah, so we can simplify the calculation a little bit. So I heard a pretty good idea of how we can decide if you're going to win 2 in a row. What are the ways to win 2 in a row?
So you either win the first 2.
Okay. Either you win the first 2, so we can calculate that.
Or you lose the first one and win the second 2.
Ah. Okay.
Yeah.
So that's it.
Yeah.
That encompasses all the probability. Sorry, not all the probability. All the possibilities. Mm-hmm. You win the first 2, and then it doesn't matter what happens in the third game.
Yeah.
Or you lose the first one and win the second 2. Okay, so let's see. With the numbers we've chosen, it's a half against the father and a third against the champion. Mm-hmm. So, in the first one, what is the probability that we win the first 2 games?
So 1/2 times 1/3. So it's going to be 1/6 because this one doesn't matter.
Okay.
So maybe
Let's write that somewhere.
remember that's a half and a third. So win first 2 is 1/6.
All right.
And then win last. Then we have to factor in the extra
So
half.
it'd still be a half, and then a third, and a half.
Okay.
Almost
So-
went together. So you get 12.
1/12.
All right. So what does that equal?
So this is,
I think 3/12, so a fourth.
yeah, this is 1/4.
All right. So in this situation, we have a 1/4 chance.
Alright.
Okay. Good.
Alright, so here, when we win the first 2, it's going to be a third times a half.
All right.
So this is also 1/6. But then winning the last 2, it's going to be a third times 1/6. So it's going to be 1/18.
What were you calculating there?
It's so we lose this game and win these 2.
Okay. So how does that work?
So you have
Just 2/3.
Or
times
2/3,
a-
yeah.
A half times a third.
so it's like
So
this
it's
is
2/18,
2/18.
so it's
So
1/9. So it does seem we have little larger numbers on this case.
1/9 is bigger than a 12th. If we want to add them, we could.
But
So
yes.
this is 5/18.
Okay.
Oops.
And is that bigger than a 4?
Yes, it is.
All right. How can you tell that 5/18 is
If you
bigger than a 4?
multiply 5 by 4, you'd get 20. So
Very good. All right. So what made this bigger? What was the situation? What was the even just the math that made this bigger? The
Well,
second one bigger.
we had the probability of winning the first 2 was the same since you had the same opponents but in a different order.
Mm-hmm.
But losing the first one and winning the last 2 had a higher probability because you have a higher probability to lose this game than you do to lose the game with the father.
Uh-huh.
And then it's the same probability to win these 2 games. So you have a higher probability in the first one.
Okay. Cool. Now let's see if we can solve the problem in general instead of just with specific numbers.